Hello, mathematicians. It's Mrs. Post here. Today is Friday, April 17th. I hope you all are excited that it's Friday and you have a couple days to relax with your family and not get new lessons coming through Teams. I know I'm excited to take a break on recording lessons. It definitely takes me a few hours to record every single day to prepare them and get them ready and get you guys all your documents together because everything I give you guys I generally make except for your worksheet you guys have been working on this week. So today is today is our last day of the 6-5 lesson, Operations with Radicals. We're going to finish it up with a division lesson whenever you have those radicals in the denominator, but in this case they're going to be binomial radicals. So I'm going to show you what those look like and how to work through those today. But before we get any further into today's lesson, I want to be able to go through the work from yesterday so we can kind of clear up any misconceptions you all might have. So let's go ahead and go over to the classwork you guys have been working on all week. I hope you have liked the fact that I didn't give you a new page every single day. We just took this lesson and just kind of chunked it into small pieces. I know what we're doing can be really challenging for a lot of students, so I didn't want it to be challenging for you. In addition to having a lot of work to do. However, there's a lot of research and science that the more you do in math, the better you get at it. So we know that. Albert Einstein knows that. Albert Einstein has told us that. I have told you that. We know it's true with mathematics. The more you do, the more you practice, the more you understand it. And the better you get. So regardless, we are still in a weird situation right now with the remote learning. So I just wanted to kind of balance out the challenging lesson with the amount of work. Just hopefully you guys are doing the little amount of work I'm giving you. So if you're not doing it, then you probably would have a problem. So make sure you are. And I know some of the people who were confused a couple weeks ago seem to be doing the work now. So that's a really good sign for me. Hopefully it's working out for you guys too. Anyway, so let's go ahead and take a look at the green problems. You guys, for Thursday, we're supposed to work on problems 5, 6, 7, 8, and 9. I didn't show them all on here, just a couple I want to go over specifically that I know you had questions on. I want to go over number 5 quickly because it's a cube root. I want to remind you that it doesn't matter if it's a cube root. As long as the index is the same, you can go ahead and multiply them. So you can tell it's a multiplication problem because there's parentheses and there's a cube root of 2 on the left. So you're just going to distribute that cube root of 2. So you can distribute cube root of 2 to this first term that's a cube root of 4. It's really going to be 2 times 4, which is really 8, right? And I didn't write the 8. I just wrote it like 2 times 4 because I just wanted you to see it was multiplication. And I want you to remember that 4 is really 2 times 2, right? So 2 times 4 is really 2 times 2 times 2. And it's a cube root. So because it's a cube root, you're looking for sets of 3. Well, guess what? We got a set of 3 right here. So that's why it simplifies to just 2. It just simplifies to just 2. And then over here, you've got the cube root of 2. You're going to distribute that to the cube root of 12. So just as a reminder, this got multiplied here, and then this got multiplied here. So 2 times 12, you guys know, is 24. But why make the number bigger if you have to simplify it? Let's just keep it small. That's what I try to do if I know it's going to get simplified out. Unless I know the number is going to be prime, then I just kind of leave it. But anyway, 2 times 12 is 24, but I'm not going to write 24. Once again, I'm just going to kind of rewrite that 12 as 4 times 3 or 3 times 4. You guys could even do 2 times 6 if you wanted. I'm just kind of writing it so I can kind of visualize. I need 3 numbers. I want to reduce this because your job is to look at it. Your directions are to simplify. So that means you're trying to get as many numbers out of that radical symbol that you can and get everything outside of it and try to get rid of it if you can. So I'm looking for 3 numbers that are the same. Well, 2 times 4 times 3. 3 is prime. I don't see any other 3s, but that 4 has 2 2's in it, right? So that would be 2 times 2 times 2. That's 3 2's. So that's why I go ahead and pull that 2 out and I leave that 3 on the inside. You can't combine them. They're not like radicals because we have a number 2 here. It's a constant. And then a 2 times a cube root. I'm sorry. That's a cube root. I got to fix that. That's a cube root of 3. There we go. So it's 2 plus 2 times the cube root of 3. And you can't combine those because the 2 doesn't have a radical with it. So that's it. You do the same thing with number 6. You should have gotten 18 times the square root of 5 for number 6. And then I did not show you number 7. that one was just kind of foiling for number 7, and you should have gotten 29 plus 14 times the square root of 7. If you need help on that, you're welcome to ask me. I'll quickly show you number 8 though, because I did work that one out for you. So this is just a review from Thursday's lesson. So real quick, whenever you guys FOIL, you take the first 2 terms and multiply them. So it's 6 times the cube root, I'm sorry, why did I say cube root? 6 times the square root of 3 times 3 times the square root of 3. So you multiply your numbers together and then your radicands together. So I know 6 times 3 is going to give me 18. I'm going ahead and I'm taking it another step by now. So when you guys notice that you're doing 6 times 3 is 18, but look, the square root of 3 times the square root of 3 is 9. What's the square root of 9? 3, right? So I just went ahead and just wrote 18 times 3. And I am going to simplify that down to 54. So I try to keep them all the same color, if possible. Okay, so I multiplied my first terms. Now I'm going to multiply my terms on the outside. So I'm going to take that 6 times the square root of 3, and I'm going to multiply it over here times that square root of 2. There's really no number in front over here, just like a 1. So that's just 6 times 1, which is 6, and then the square root of 3 times the square root of 2 is 6. Like I told you, 6 isn't going to get broken down because it's 3 times 2, and there's no pairs in there. It's just 3 times 2, so it's going to stay. So I just go ahead and multiply it out. All right, now go ahead and work on your inner terms. So you have a negative 4 square root of 2 times 3 square root of 3. So negative 4 times 3 is going to give you negative 12, and then a square root of 2 times square root of 3 is going to give you square root of 6. All right, and I'm already seeing that these 2 terms right here in the middle are gonna, you're gonna be able to combine those because they're both like radicals. They both have a square root of 6 in there. We'll do with that on the next step. And then we're gonna go ahead and multiply our last 2 terms together. So negative 4 times the square root of 2 times the square root of 2. That's gonna be negative 4 times the square root of 2 times the square root of 2. And I know the square root of 2 times the square root of 2 is 4. And the square root of 4 is 2. That's why I go ahead and just take it down here at this point. I just want you guys to kind of see how I'm kind of working it out a little bit faster here, because it's the, been doing it for a few days. So it'll be negative 4 times 2, which is going to give you negative 8. And then when I go ahead and combine these terms in the middle, remember you just add your coefficients kind of. So it's 6 plus a negative 12, which is negative 6 square root of 6. And then I will go ahead and combine my 54 with my 8, and I get 46. So I write it as 46 minus 6 times the square root of 6. You could flip it and write it as a negative 6 times the square root of 6 plus 46. That's fine too, but that's generally just the way I'm writing it, trying to keep that positive number on the left. And then whenever you guys work on number 9, that one should have canceled out just the way it does, and you would have ended up with just 60. So that's what you guys should have gotten for 9. So if you didn't get that, make sure you go through it and check it again. All right, so you're only going to do 3 problems today for your classwork, 10, 11, and 12. So not too many problems today. They're pretty quick. You just have to kind of get used to the process. And we've done this in pieces throughout the school year, so we're just adding them all together kind of at this point. So let me get to today's notes. So at this point, if you don't have your notes out, you need to go ahead and get them, pull them up on your computer screen, your phone screen, your tablet screen, print them out, get a piece of notebook paper, and follow with me. All right, if you need to pause the video, do so. Okay, so we're going to work on simplifying these radicals using conjugates, and we've talked about conjugates before when we've worked with imaginary numbers. So, because you know how you can have like 2 imaginaries always come in pairs, a positive and a negative, kind of the same thing here. Maybe you remember from geometry, the golden rectangle or the golden ratio. This is where this kind of comes into play. So the ratio of the lengths of the sides of a golden rectangle is 2 over the square root of 5 minus 1. All right, so you have a radical in the denominator. You know, the rules say you cannot have a radical in the denominator. You know you cannot. So based on the lesson you did this on Tuesday. On Tuesday, you worked on the quotient property of radicals, and you know you're not allowed to. So you guys had to rationalize the denominator. We have to do the same thing here. The difference is, like for example, if you look at this example right here, I'm going to go ahead and write on here. You guys should see that, you cannot have a radical in the denominator, cannot have. So what do? Remember, you have to rationalize the denominator. This is not new. This is from Tuesday. rationalize the denominator. So remember, you would have to multiply the top and the bottom by the denominator, right, if possible. And so in this case, you would get 2 times the square root of 3, and your denominator would become square root of 3 times the square root of 3, which is square root of 9, which is 3. And so you are kind of manipulating it to get that denominator as just a regular number, not as a radical. Okay, otherwise it would be irrational and you cannot have that. So we're going to do the same thing here. The only difference is that it's a little bit of an extra step because your denominators are going to kind of look like this, but with a square root on them. So they're kind of going to look like the square root of 3 plus 1, or in this example right here with the golden rectangle, square root of 5 minus 1. So you see how it's a binomial? That's what we're doing today. Same exact process. We're taking the multiplication lesson from yesterday, the FOILing, and the dividing, rationalizing the denominator lesson from Tuesday, and we're putting it all together. All right, so just remember, conjugates mean the opposite. So for example, these are not radicals. Just kind of take a look and see. 3x plus 1, what's the conjugate of 3x plus 1? Well, the conjugate of 3x plus 1 is 3x minus 1. You just change the sign and flip it from positive to negative. You could do the reverse as well. And I think we talked about this with imaginary numbers too. So a plus bi, the conjugate of that is a minus bi, right? If you have a minus bi, that conjugate is a plus bi. You just flip the sign in the middle. Change it from subtraction to addition, or addition to subtraction, or positive to negative, or negative to positive, if that's how you think of it. So we're going to do that same thing here. So I put that there for you guys to see. Here's a little cheat sheet for you guys. They don't always look like this. So remember, what you're going to do is when your denominator has a binomial radical, like a plus the square root of b, you're going to multiply it by a minus the square root of b, right? And then you're just going to FOIL it out. And coincidentally, what's going to happen is it's kind of like the I don't know what I was thinking. Sorry. When you multiply it out, you'll notice that the radicals will cancel. And it's going to work like that every single time. So if you want to have this pattern out, go for it. You can pause the video and write it down. But I did just get this from the internet, so feel free to do that. But all the problems we have today are not always going to look like that, where you have the square root and then you have, it might be like square root of 5 minus the square root of 2 or something like that. So they might not always look like this. So I'll show you. All right, let's go ahead and do example number 1. I'm going back to the original when we were talking about the golden rectangle. So it says, given the ratio of the lengths of the sides of a golden rectangle, 2 over the square root of 5 minus 1, use the conjugate to rationalize the denominator and simplify. So we're just going to do what we've been doing with multiplying. I'm going to give us a little bit more room here. All right, so we're going to go ahead and simplify this, but we got to get rid of that radical here. So we're going to multiply it by the conjugate. Okay, so if we're going to multiply by the conjugate, remember what that means is we're going to multiply the top and the bottom by the conjugate. So the conjugate of square root of 5 minus 1 is going to be the square root of 5 plus 1. All right, and whatever you do to the bottom, you have to do to the top. So we're also going to multiply the top with the square root of 5 plus 1. All right, so we're going to do the same thing, top and bottom. So I'm just going to go ahead and show you that we did that. We multiplied the top and the bottom by the conjugate. So I'm going to go back over here. I'm going to change this to dark blue. Okay, so let's go ahead and do that. So we have 2. So our numerator is 2, and we're multiplying that with square root of 5 plus 1. And now our denominator is the square root of 5 minus 1, and we're multiplying that to the square root of 5 plus 1. So now you can see it's kind of like what we just did on Thursday, but instead we have a numerator and a denominator versus just a numerator. So that's really the difference here. So just go ahead and multiply it out. So 2 times the square root of 5 will be 2 times the square root of 5. We're just distributing, and then 2 times 1 is just going to give you 2. So you went ahead and simplified your numerator. Let's do the same thing with the denominator. So you're just FOILing it out. So and it's actually not too bad, like I said, because their goal is to get rid of the radicals in the denominator, and they go away. So it's actually kind of better to do it like this, because I know you guys are like, oh my gosh, there's so many radicals. But when you do this, they go away. So it's actually okay. So look at it. The square root of 5 times the square root of 5. Well, that's square root of 25, which is just, can I just write 5? Right? Do you want me to write square root of 5? I can. square root of 25. I can do that, but no, it's 5, right? And go ahead and then multiply your outer terms. So square root of 5 times 1 is just the square root of 5. And then you're going to multiply the inner terms. So that is going to give you plus a negative 1 times the square root of 5. And then one more, your last term. So it'll be negative 1 times 1. And I'm just going to extend my line here because that bottom got a little long. All right, so we know our top was 2 square root of 5 plus 2, and our numerator here, square root of 25, you guys, is just 5. And look at this, we have the square root of 5 and we have plus a negative square root of 5. So hopefully you guys will see that these right here are just going to cancel out. And that's what I'm talking about. Those cancel. So it's actually really beneficial to do this. And then you have a negative 1 times 1, which is just 1, which is really just 4. So technically you guys are going to get 2 times the square root of 5 plus 2 all over 4. All right, so it's not too bad. It's just what we did on Thursday, just adding a little bit more to it. Now you can simplify this some more, and this is where fractions come into play. A lot of you guys don't like fractions, but they're actually not too bad. You just divide numbers with numbers here. So hopefully you guys can see we're just going to simplify here. 2 and 4. If you have 2 over 4, you guys, I'm just going to make a little note. You can simplify that to 1/2. So that's really just becomes a square root of 5. And your denominator is going to be 2. You're going to do the same thing here. 2 divided by 4 is just 1/2. So just plus 1. And you just share the denominator. That's all that means. That 2 on the bottom just means that denominator shared. That's all it means. So you can leave it like this, or you can leave it like this. Either way is okay. All right? Either way is okay. Just want you to see that you can simplify it a little bit more. All right, we're going to do a couple more examples. And like I say, same exact process here. We're just trying to get rid of the radical in the denominator. So hopefully you guys can catch what the conjugate is here. You have 9 minus 2 times the square root of 3. We're going to divide that by the square root of 3 plus 6. So we have to multiply it by the conjugate. This is a binomial here. So what's the conjugate? Well, hopefully you guys can see that that is going to be square root of 3 minus 6. Just change it from addition to subtraction. That's it. And so you're just multiplying it. I'll put parentheses here. So you're just multiplying, or in this case, FOILing. Okay? That's all you guys are going to do. So we'll go ahead and FOIL this out. I'll put a parenthesis here if I want. Doesn't really matter. Just remember you're multiplying. 9 times the square root of 3. 9 times negative 6. And then we're going to multiply the inner terms here. It'll be plus a negative 2 square root of 3 times the square root of 3. Hopefully you guys are going to catch those square root of 3s are going to cancel out. And then lastly, we're going to multiply plus a negative 2 square root of 3 times a negative 6. And that's our numerator, right? Looks messy, but once we simplify it out, it'll be fine. Go ahead and multiply down here again. I feel like I should change colors, but I feel like you guys have FOILed for so many years that we should be okay at this point. I'm not doing the box because it's just a binomial times a binomial. So the square root of 3 times the square root of 3. Hopefully you guys are seeing that is the square root of 3 times the square root of 3. And then you have the square root of 3 times negative 6 plus the square root of 3 times negative 6. And then we're going to multiply our 6 times the square root of 3. And then our last terms, 6 with the negative 6. And I'm trying to keep it positive or like addition all the way, then I'm just kind of putting the negative with the number, if so. So you guys at this point should be able to simplify. 9 times the square root of 3. I'm just multiplying the top here. 9 and 6, you guys should have what? Negative 54 here. And then when you multiply negative 2 times the square root of 3, that's going to be negative 2. Square root of 3 times the square root of 3 is 9. Square root of 9 is 3. So that should be negative 2 times 3 should give you negative 6. And over here you have negative 2 times a negative 6. That should give you a positive 12 times the square root of 3. That should be your numerator. I bet you we can simplify some more though. But let's go ahead and take a look at the bottom real quick. Let's take a look at this denominator. All right, so with the denominator, hopefully you guys are seeing this is -3 times -3, square root of 3 times the square root of 3, which is the square root of 9, which is really just 3. And over here you guys have plus, looks like a -6 times the square root of 3. And then right here you have a +6 times the square root of 3. So hopefully you guys are going to see these right here are going to cancel out. And then you have +6 times a -6. So there's your -36. I'm going to go ahead and just change my pen. Look, you guys, those are going to cancel out. That's what you want to see, right? So let's go ahead and combine like terms and get our final answer here. So it looks like this top is going to have, look, you can combine this term with this term. So 9 plus 12 should give you what? 21 square root of 3. And then you guys have 54 and 6. When you combine those, you should get -60. And then your denominator looks like it's going to be 3 plus a -36, which is going to give you a -33. And I would be okay with that, but you should be able to reduce that a little bit. I know -33 is really like 3 times 11. So you could divide the 21 by 3 and the 60 by 3, and you should be able to simplify it some more. So just know that I would take this, but you have to be aware that you can simplify it further. So if you divide 21 by 3, this is a negative, so I'm going to divide both sides by this -3 just to simplify it. So 21 divided by -3 should give you guys a -7 square root of 3. -60 divided by -3 should give you guys a positive 20, and your denominator should be 11. Positive 20. That's right. So I would take any one of those, but just remember, technically, if you can get your numbers as small as possible, that's what you want to do. So we just divided 21 by -3 and -60 also by -3, just to make our numbers a little bit smaller. All right, so here's our last example here. Example 3. You guys have the square root of 2 times the square root of 2 plus 2 times the square root of 5 divided by square root of 5 plus square root of 2. So you guys need to go ahead and multiply this out by the conjugate and go ahead and see if you guys can work this one out. So I'm going to pause the video. You guys pause it too and try this one on your own before you go further. It's a really good indicator that you know how to do it. Okay. So your conjugate that you multiplied by should have been the square root of 5 minus the square root of 2. And you guys are going to FOIL, just like you've been doing. And hopefully on the top you did that. And I can see where I can simplify the square root of 4 here, the square root of 25 here. Down here, the square root of 4. I'm also seeing the square root of 25. I'm also seeing that these square root of 10s right here are going to cancel. If you have a positive and a negative, it's just like the coefficient was 1, they would cancel out. So I'm going to go ahead and bring it down here and just continue working my way through. But look at this. Like, I'm trying to simplify this out, and hopefully you guys are catching the exact same thing, and you see what I mean by this 2 square root of 10, when I add it to a -2, that's going to cancel and become 0. So that's awesome. So then what you're going to have on the top is -2. This is -2 times 2. Am I right? Because the square root of 4 is 2. That is -4. And this is 2 times the square root of 25, which is 5. 2 times 5, that's 10. And that's all you have on the top. So hopefully you guys are seeing right off the bat, that numerator just becomes 6. It's very, very quick to simplify once you multiply by the conjugate. All right, let's handle the denominator. The square root of 25, hopefully you guys can see, is 5. And look at this, a negative square root of 10 and a positive square root of 10, those are going to cancel. And the square root of 4 is 2. All right, so really your denominator here is just 5 minus 2, which is just 3. And what's 6 divided by 3? That is 2. And that is your final answer for example 3. So hopefully you guys were able to work it out and simplify it. If you need to go back and watch any of these, you can. Remember, I want you to be able to simplify these. It's really not a big deal. It's just changing the denominator and changing the numbers a little bit. Try it, get as far as you can. This is why I like you guys to show your work, so we can see where you're getting stuck or where you're not. So anyway, your classwork for today is just to go back to the assignment you guys have been working on, and you guys are just going to finish 10, 11, and 12. Do them on here or on notebook paper and send those in for Friday. And hopefully you guys were able to get that exit ticket finished in Socrative. If you need anything, just let me know. And I will be here from 10 to 12 and 2 to 4 if you guys need me. And sorry the video was so long, but you're welcome to pause it, and you only go if you understand it on example 1, then you guys are good to go. You don't have to finish it. Anyway, so happy Friday. Come see me if you need help. 10, 11, and 12 is all you need to do today. And then plan for some mastery assignments next week on these topics. So come see me today if you need help. And that is it. Have a fabulous day and hope to hear from you and see you in the post office. Otherwise, happy Friday. Bye, guys.